and Windows.
Thanks, Veronica. Hey everyone, I'm Tommy Jensen. I'm from Microsoft, though as other speakers have said, I am here giving you my personal opinions. I don't speak on behalf of the company. Next slide, please. Or do I have a clicker?
Yes, you have a clicker, sorry.
No, that's quite all right. Thank you. Okay, so before talking about anything else, a few of you may have heard that we did a blog post earlier this year talking about a specific IPv6 feature. I asked the public with a survey, what is it that everyone actually needs from Windows in the modern world to support an IPv6? And we got hundreds of responses, partially in thanks to this community, who really dug in, reached out, and asked others to participate. So thank you so much, both for being a welcoming community to those of us who are newer to IPv6 and for helping get signal to where it needs to be. It was really helpful and will inform a later slide in this deck. I'm going to start off with just going over a few things of what Windows has done before we talk about where Windows is headed. Because honestly, some of the history is pretty fascinating, especially because where we are present as a platform in all places in the network, primarily our work focuses on Windows as a endpoint, where from it to a router is our support, and the larger network is handled by the people in this room doing other things. And so the technologies are sometimes different. So this isn't even that many protocols, but these are all protocols that have at least had some support in Windows or still do. And when I actually have been working in Windows on IPv6 for only about a year. I started in networking 5 years ago doing other things like DNS and HTTP. And when I dug into this area, going down the list of the things that Windows has added to support IPv6 was pretty daunting. These are the heavier hitters, some of which we adopted from open standards, right? Like 6/4, 6/4. Some of the others we actually helped develop in public space, like Teredo and ISOTAP. IP-HTTPS is something that we actually built that's proprietary rather than being an open standard, which is not my favorite, but solved a pretty interesting problem where we were having UDP traffic blocked, and so Teredo tunnels were not working for the primary business use case for a large corporation serving other large Fortune 500 companies of gaming, which is really important for peer-to-peer networking that we went IPv6 to before other technologies. So I'm going to actually do a lot of the talking here paused on this slide, because this is something that seemed to get a lot of interest from people to really show how IPv6 in Windows looks over time in perspective, because tables are boring. In that first line, which by the way, please don't hold me legally responsible for pixels v the years, it's rough. But that far to the left is mostly Windows XP. IPv6 was actually optional at first, which was kind of a giggle for me until I realized, like, yeah, I guess it has to start somewhere. And then you'll notice we actually rapidly added support for all these other technologies, one right after the other. 6/4 did not last long because, hey, it turns out 6/4 can do it much better. But what strikes me is in dealing with customers and dealing with scheduling investments with work, a common theme that I hear repeated over and over that I'm sure this room can relate to is we're never going to be IPv6. We need to focus on IPv4. And what I love looking back at this kind of 20+ year perspective is that we actually have come a long way, not just in the percentage of people using IPv6, but these technologies are about moving IPv6 traffic over IPv4 because we needed to have connectivity with IPv6, but networks were just presumed to be IPv4 networks. And that's not the case anymore. Right now we're talking about needing to move IPv4 traffic over IPv6 because we assume that if we're going to be missing one, we're going to be missing IPv4 on the network. And so that's a huge kudos to everyone in this room, right? The networks have moved to that regard that now as platforms, we are now worried about the opposite problem, which is how do we maintain the right tail of IPv4 rather than how do we support the right tail of IPv6? And so you'll see that 6.4, ISOTAP, and Teredo all went through a step-by-step deprecation out of Windows, which honestly, in as long as they've been deprecated, not everyone knew, which I thought might be interesting. But the next line tends to catch people because this year we deprecated a feature called direct access, which was what we had before always on VPN, which is what we recommend people use now instead. But direct access is where we support DNS 6.4, for example. And so there's actually kind of a lot that goes missing when you don't use direct access, including IP HTTPS, which defines IPv6 traffic only over HTTP connections. There are better solutions to that standards-wise, including the latest being the MASC protocols out of the IETF, where you can do IP or UDP over HTTP. Great. You'll notice that DHCPv6 didn't come right away either. We were honestly, well, I say we, I was not here yet. It would be lovely if we only had one way of managing address allocation and configurations in a network. And yeah, I know this room can deeply appreciate. And so DHCPv6 is something we do support. And we will continue to support. It's just a shame that, we were hoping to get away without it, I believe was the strategy, and I can definitely see why. Nevertheless, it did show up later, and I think for that time frame, we're talking about the Windows Vista release. You'll notice CLAT's on this timeline. CLAT, as part of 464 XLAT, was actually added to Windows after it was, this is when it showed up in desktop and server and the SKUs you're normally familiar with, but it was added years before 2017, because that's when it was added to Windows 10. It was added years before that to a SKU called Windows Phone. I don't know if anyone heard of or remembers Windows Phone. Cellular networks went to IPv6 much faster than your home ISPs did. And so we were actually under pressure pretty early to make sure that Windows running devices that supported cellular partners out of the box could use 464 XLAT. And so the code has actually been there for years before this. And so for roughly 10 years or so, give or take, Windows has supported CLAT only for cellular networks. And so that's still true if you have a Windows device that can use a SIM, uses eSIM, etc. CLAT is there. It's just not supported in the interfaces that we typically use today, right? Wi-Fi and Ethernet at scale. There's a long slew of other technologies that I didn't list here that really show like the industry's journey has been very long, and we've done a lot, but as you saw earlier this year, we're noticing a big trend shift that was discussed in talks earlier today of there are many governments with mandates that they need to move to IPv6. We have markets that have de facto mandates because they're running out of IPv4 that prompt us to ask, like, supporting IPv6 is one thing. Like, Windows supports the IPv6 protocol. But there's a huge difference between supporting IPv6 and robustly supporting IPv6 only. Huge difference, right? And anyone who's attempted to go from dual stack to IPv6 mostly knows what that entails, because you realize how much of your network was running because someone turned off IPv6 during troubleshooting 3 years ago and left it off because they could close the ticket. So we also, right, we run into some of those same things where it's like we work in dual stack. What is it that doesn't work when we go only? And so we can come back and revisit this, because I'm going to go a little back and forth, but we're just going to jump to that point because I want to talk about where we're headed. And it's to add CLAT to all the network interfaces that Windows uses, right? That survey that everyone was very helpful in filling out, was incredibly clear. I listed a bunch of technologies, asked people how they do various deployments, and then at the very end, I left an open-ended question that said, tell us what it is you would want. Like, what do you want to tell the product team? And that was it. And I got 3-digit number of responses and a 3-digit number of direct mentions of CLAT. And the next most commonly mentioned technology was mentioned by less than 5 people. It was so clear that this is what the industry wanted, which honestly was pretty eye-opening because, as you've seen, the field is wide. And I go, yes, the field is wide, right? And this is such a subset of technologies that have been involved that people are like, yeah, but there's really only this one that we care about. And so we deliberated internally on what was going to work for us and what we were going to build. And when we came to the decision that we were going to build CLAT, I issued a blog post about it. And then my inbox got DDoSed by all of your colleagues of apparently this is what everyone has wanted forever. And we just hadn't heard yet, weren't paying attention, whatever. I'm glad that we're here and engaged. And I'm glad that everyone here is running these forums where we can gather because we didn't know. But here we are. So I told a number of you offline before this talk, and I'll just say it now before we get to the Q&A. I don't have a timeline for you. It's coming soon, trademark. That said, it's something that we are going to be looking for help in doing self-hosting on. So I can promise you that you will get very noisy signal from me publicly at every step where we say, okay, now we're looking for self-hosters. And I'm hoping to get that same energy and help us find all our bugs because we're doing our best. But clearly in the diversity of networks being deployed, just the diversity from what we saw in today's talks already, frankly, there will be things to uncover for certain. So in addition to it's what the people want, there are some other motivations for CLAT that made it attractive for us as good. We don't need to invest in A, B, and C, and I'll leave A, B, and C undefined, and you can all pick your least favorite text and fill in the blank. For realism, we have a lot of customers who aren't using IPv4 because they love it. They're using it because they have to. They have some vendor application that is IPv4 only, and they cannot replace it in the next 10 years or 20 years, in at least one case I heard, where it's like, whew. And so they have to use it. It can't be modified. The OS can, though. So it would be great if the application could speak to an IPv4 endpoint with no knowledge that it doesn't actually have IPv4 connectivity. Because there are other approaches to transition text, but not that as gracefully leave the application in the dark. Some other competitors already have CLAT in their operating systems, and wouldn't it be lovely if we had some consistency across platforms so that network admins could deploy one solution and have it work for all their devices? Be nice. And as discussed, like we already have CLAT. We just need to expand it and make it configurable in ways that are useful for your other network types, which there was one blissful day when I first started on this project where I was like, cool, so we're going to remove an if condition and have it activate for other network interfaces. And that was a wonderful day. It was a wonderful day. I'll remember that for the rest of my life. There are a lot of interesting complications with CLAT that depend on your network environment. I'm trying to decide if I put anything useful in the next slide about that or not. I didn't. That's fine. I'm going to leave this up and we're going to talk about it. So there's a lot of work going on in the IETF talking about various good practices with IPv6. I know Jen's in the room. Hi, Jen. Is authoring a draft about CLAT recommendations for implementers of when and how to activate CLAT that is honestly partially inspired by me coming to Jen and being like, we learned some interesting things, maybe we should write them down, where there are many ways of deploying 464 XLAT, and some of them are more correct or more preferable or more hated than others. And I'm actually going to mention a couple just in sharing with you what Windows is thinking about, also kind of provocatively tease the room into telling me why I'm wrong, because if I am, I'd love to hear opinions. There are 3 different mechanisms for discovering the translation prefix provided by a network. One of them is sending a DNS query. One of them is retrieving it from a router advertisement that you're already getting. And one is using a protocol called PCP, which everyone has widely implemented. We have a strong preference for using RFC 8781, which says get the prefix from a Pref64 router advertisement. Because, hey, we're already getting those. From the Windows perspective, we are also building support for the DNS mechanism because at the current state of affairs across the industry, it's needed. And we want to meet people where they are and not just build the one way that we think it should be built and then have everyone adapt to us or choose between platforms and say, well, we want to be interoperable, right? But we have a strong preference for not doing DNS discovery of the prefix, which is why that second bullet is there, where I am working with others to say, hey, we should just deprecate that altogether. So if you love that mechanism for some reason, please send me mail and or Q&A. But another one that I don't have mentioned here, but I'll talk about, there are 2 different kinds of prefixes that can be advertised for CLAT, right? There's the well-known prefix, which is hard-coded in RFC, and then there's just arbitrary, the network-selected prefix, network-specific prefix, there it is. When using the well-known prefix, there's some odd little gotchas that a lot of customers I've talked to don't seem to care about, but some do and did not realize there was a gotcha. For example, you can't use the well-known prefix to translate traffic to another RFC 1918 address, meaning you can't have IPv4 traffic go over a local network between local nodes if you're using the well-known prefix. Please don't use it. If you, for some reason, find you just love the well-known prefix and there's some challenge with deploying network-specific prefixes, please tell me because I don't want to do things. Again, if the network advertises it, sure, but that's actually something that we don't intend to treat that as its own automatic mechanism. We don't want to just use it, and if the network happens to be listening for it, that'd be great, because that would actually be a bad thing for an unintentional PLAT to pull up traffic. So you would have to advertise it anyway. Please make one up instead, but be advised. Another one that I don't know, this room will probably be fine with, but the IETF hilariously wasn't, is we don't want addresses assigned to us, we want prefixes assigned to us, right? Like using PD, using Slack to be able to generate a checksum neutral address for use by the CLAT node so that we have a dedicated address that we can use makes way more sense. We can be stateless and we can avoid doing header recalculations that end up with a bug surface or just erroneous errors and edge cases that result in poor ISPs having to have an exception point where they have a different route switch just for those packets. So I read on the internet. And so we, if you have a strong opinion about, I want to be able to assign specific /128s for some reason, please Q&A for that, but that I definitely will be a little more hardline with, because please give us prefixes. These are a few of the things we've uncovered that are more obvious of like, hey, there are many ways of doing this that affect how we build the support. And so I'm hoping those inspire some ideas, but if you have others in your head that you're thinking, oh, but this would also be a problem, like, here I am. So yeah, this is the major direction that we're headed right now that I've already announced. We can talk about it. I don't have a timeline for you yet, but this, to answer the question of, we have a Windows fleet, how do we enable IPv6 mostly? This is the answer. And I want this to be the only answer. I don't want this to be a, well, then there's this other protocol. No, the next time I want to revisit CLAT is when we are IPv6 only globally and we're deprecating transition text. That's what I want. I forget this is such a friendly room. I'm used to people being like, that's never going to happen. Yes, it will. Yes, it will. Cool. So I purposefully left this a little open-ended because from prior experience, I have a feeling there's going to be questions, and I figured I may as well just react to those instead of telling you things you may not want to hear about. I've left my email address up here. That's a J, not an I, underlining silly. But the slides, I assume, will be on the website. Anyway, please reach out to me. I work in the public space for standards development. Also, just let me know what questions you have. I may or may not be able to get to you quickly, but we want to hear. Tell us about what you found in Windows where you're like, did you know that this doesn't work really well because you assume IPv4? That would be useful. Have you thought about this IPv6 use case? All ears. I represent a very talented group of engineers for whom I am a PM mouthpiece. So please, let me pass it along. So Q&A, if there is any. Amazing. All right, there we go. I was so close.
Hello, Nick from BT. I don't know whether I'm the only cellular type.
I can't hear you.
You can't hear me? Speak up. Any better? It's Nick from BT. I don't know whether I'm the only cellular person in here. Shout if you're into cellular. But one of the cool things about RFC 7050 for us in cellular is that the announcement of that kind of NAT64 capability comes from the firewall gateway rather than from the immediate router, and that's quite cool because the router is actually the PDN gateway. And the handsets, all the traffic's in tunnels. So in dealing with the kind of the router, the RA type approach, it kind of everything's got to be in tunnels and everything's got to be sorted out by that box, and it's got to know all the services, all the different types of APN. So by pushing it back and having the DNS kind of do it all, it's kind of cool because you just want one DNS for your whole network, and you kind of announce it there. So I don't know whether that's a question or just a comment, but
no, that's useful signal. I'm curious, and this is naivete, right? Because I work on a platform and not a network. When you talk about it being easier, what I'm also hearing is you're pulling back, you are broadening the responsibility such that the same prefix is being used many more places than you have routers, right? And so the question I have is that ever going to be a problem where the DNS server I'm speaking to is going to give me a prefix for a router I'm not talking to?
So, I mean, this is just about finding your well-known prefix or the fact that NAT64 is in play, yeah? So
yeah, the network-specific prefix, because you're going to stop using the well-known prefix.
Yeah. So, okay.
No, that's interesting. I had not considered that there would be significantly higher difficulty in getting configuration synchronicity at the routers handing out advertisement than it would be at the DNS server the clients are using, which I think is the point. That's the underlying point here, right? Is that it's easier deployments to be able to update that at the DNS server and hit everyone without having to update the configuration of routers?
That's how we're using it today.
Okay.
So, I mean, we can change it. The idea of using DNS in this way wasn't necessarily viewed as perfect at the time, and it probably still isn't perfect, but it does have that kind of global approach. Maybe I need to understand where you're going more and get on board with that. So,
well, thank you. It's not taking some of the joking tone out of it. Part of the problem is that having more than one mechanism to get the prefix creates a whole new set of problems around conflict resolution that we don't have if we only have one. And so the one being the one that we are already using to get IPv6 configuration, i.e. router advertisements anyway, is helpful because when we separate it out into the DNS, it means that we have a different attack vector created as well, because now there's two channels by which we're getting this config rather than one. And Yeah, right now the RFC say, and Jen and I are further encoding that when in doubt, when you get both, when the DNS query returns information, when you get information via router advertisements, the router advertisement always wins. And that's already true, and it will continue to be true in IETF standards as far as I am observing. And so in that case, when you use DNS, it does mean that you're going to start losing clients if any of the routers start handing out their own config, because the DNS will be ignored. And maybe that's expected. Maybe that's what you want. But it's nuanced to call out of part of the reason we would like to see a single mechanism is so that we don't have to worry about edge cases around when we choose which.
Okay.
I just want to add one thing to that on the DNS front. One issue that I think you might be ignoring there is clients setting custom DNS. So if you've got clients setting their own DNS servers, all of a sudden your prefix notification is going out the window, and clients that should be IPv6 capable aren't because they're not getting your prefix. And custom DNS isn't going to know about your network-specific prefix, whereas Pref64 shoves that into something you always control, so they're always going to be able to do Pref64, whereas DNS is very much, the user has to set their own DNS because of company policy. All of a sudden, IPv6 falls off and they're stuck in the past.
100%, because we actually have to keep track of the DNS servers the network advertised just so we can send them this query, whether or not the operating system is configured to use those servers anyway. Like if the user says, I want to use these encrypted DNS servers, because that's kind of common now, then the OS has to remember, well, these are the DNS servers that the network advertised, and I'm going to hold on to them in case I need to send this special query, which is kind of lame. Whereas the router can just tell us directly. But again, that's another factor. I don't want to argue or attempt to settle, because this is an interesting tidbit I had not heard before. And again, you can breathe easy in this room in terms of our plan is to support both. It may end up being that it's off by default and 8781 receiving the prefix from the router directly is on by default, but that's a config setting.
Yeah. One more question. So Microsoft has become a gaming powerhouse. So gaming, of course, benefits a lot from IPv6 point-to-point connections. What can we take from that world and apply it to, let's say, the corporate side of things from an IPv6 lens? Is that something that you are able to answer, or that would be somebody else that we can ask Microsoft?
So in general, everything I say here is as an individual anyway. This is especially true on this question because I don't work in the Xbox division and I don't want to speak on their product design behalf. But what I can tell you is that in the history of teleconferencing, I think the first application that solved real time-ish audio latency was a thankless little app called Mumble, long before teleconferencing did, because gamers needed to coordinate live MMO raids, right? Latency, we have gaming to thank for that from the corporate perspective. Gaming, I think, already kind of informed us. If we go here, Teredo itself is used for exactly that, right? To connect gamers over IPv6 when the network didn't have it, and to punch through NATs. And when that didn't work, there were other things created. So yes, absolutely, we should, which is honestly like, that's how I was trying to joke earlier, because Microsoft is obviously a huge vendor for large enterprises, but we are also really big into gaming. And a lot of our networking is designed around making gaming more effective. The things that we can learn from them that they take seriously, that we can apply everywhere, is really latency. It's all about latency, right? Video games don't cause violence, lag does.
Hot take for the day.
Yeah, so you quote that on YouTube. Hi, Mom.